Welcome back. Here we are. We're going to discuss our last chapter in the book, chapter 19. There's no homework assigned for this chapter. There's no homework after this, except next week you will get your test distributed on the 5th. Might even distribute it the night before, so if you want, you could take a look at that and start working on it. You have the whole week to work on it. It has to be turned in by before 9 p.m. The following week, the 13th. So just make sure that you remember to do that. And that's the last day of class. So today we're going to look at Chapter 19, Magnesium, Zinc, and Specialty Metals. It's a very short chapter. Okay, so first of all, we're going to identify the properties and commercial applications of magnesium, zinc, tin, and other non-ferrous metals. That will be on your final exam. I'll have you give me some examples of non-ferrous. Okay, and also die casting, the process. Explain tin and waveform soldering. And list properties and applications for superalloys. First of all, magnesium. Magnesium is very light, it's low density, and it's corrosion resistant. Magnesium was used a lot back in the day on cars. I don't see it used as much on cars visually as it used to. It used to be actually, that's if you've ever heard of mag wheels, like wheels that they have on cars, they used to be of magnesium. And I don't know if you could still get them in magnesium. I'm sure you probably could. But again, that was because it was very lightweight. Another interesting little story, if you've ever heard of the Pontiac Fiero, which was a car of the 80s, a little tiny sports car. And they had a little four-cylinder called the Iron Duke engine there. But it had magnesium, I believe a magnesium block, which is strange because it was called the Iron Duke, but maybe it might have been the head. Anyhow, some component was made of magnesium on the engine, and it was actually what they call mid-engine, so the engine was in the rear of the car, and it didn't, especially in hot climates, especially in the summer, it could overheat, and there were instances where actually they would start on fire. And magnesium, if you know this or not, that's what sparklers are made of. And if you've ever tried to throw a sparkler in water, it doesn't put it out. And so when these magnesium engines would start on fire, the fire department would just sit back and let it burn itself out because there was no way to put it out. Anyhow, let's move on. Okay, so some other materials. Zinc, it's inexpensive. It's a heavy metal used for alloying to enhance corrosion resistance. So, like for example, galvanizing applies a thin layer of zinc to protect surfaces. It acts as a sacrificial corrosion layer. And you guys have probably seen galvanized. Like, if you've ever been to Hobby Lobby, they have a lot of farmers type things that you might find in a farmer's kitchen. And back in the day, everything was galvanized. They would take steel and they'd galvanize it because the steel back in the day, they didn't. One of the additives we put in it now is chromium to help with corrosion resistance. But back then they didn't. Chromium wasn't as readily available. So things would rust very easily. So they'd learned that they could actually dip the metal or the steel in zinc and it would plate it. And what's interesting is you can actually see the crystalline structure of the zinc on the outside. So if you've ever seen some old farm buckets or I should say a pail and things like that, you'll see like this has that corrosion resistant layer on there. Anyhow, also die casting. Die casting uses zinc to actually form thin-walled parts for small details. So they used to make like matchbox cars from this. They were all, you'd always hear they were die cast. And so little toy cars and things like that. Moving on to tin. Tin is a very soft metal. It's used to plate food and beverage containers. It's not good for making parts as it's weak and it has a low thermal threshold, so it melts a little too early to be used for a lot of things. But solder is it's great when you use tin inside solder. So for electrical circuit boards and things like that. And there's actually in the PowerPoint, if you want to take a look, there's a little link right there. If you click on soldering, and it'll take you to YouTube if you're interested in looking at a little video at how a circuit board is put together. It shows the circuit board is already assembled, but it just goes through a waveform bath, and it automatically solders all the components to the board. It's really kind of a cool process. But if you want, I'm not going to put it up here, but if you're interested to see that little where it says wave soldering in yellow, you could click on that link in this PowerPoint and go directly there. Not in this video, of course. You'd have to open the PowerPoint by going to the vertani1.com/metallurgy.html. All right. Then nickel-based superalloys used for aerospace applications and high thermal thresholds. What's really fascinating is some of you might have passed by Alloy, which is literally right down the street from us on campus, very close to the welding building, just a few doors down, in fact. And if you ever stop by, they actually do give tours from time to time, but you have to prearrange that. Anyhow, they actually specialize in these nickel-based superalloys, and they used to make parts for the space shuttle, for military aircraft as well as civilian aircraft. They still do. It's a very good company to work for. It'd be a great tour. Unfortunately, since we're not in class, we can't do it, but definitely might be one of those things on your bucket list if you're interested in that sort of thing. Okay, titanium. It's very low density. It's corrosion resistant, has a good thermal threshold. Very expensive. It's used in aerospace quite often, and it should be welded in an inert atmosphere. And during the class, I used to show you a video, and I'll see if I could put the video link up there. But I had a video on welding in inert atmospheres, so it's really pretty cool. And you'll see they actually use titanium. In fact, titanium tubing, and they weld it together to make a tubular frame. Pretty cool stuff. It's actually like, it looks like they actually took a sandblaster, the actual housing, and they just converted it to the opposite, where they pump in an inert gas. I forget which gas they were using in there, but basically pretty neat. I'll try and find that and put that link on for you so you can watch that. And if you do watch that, if I do get it up there, and if you watch it, I'll give you some extra credit if you tell me a couple things you might have learned. Okay, finally, gold. Gold is corrosion resistant. It's ductile. It has a high density, used for casting, of course, jewelry, brazing, soldering. It's great for dental. It's also used for electroplating. Now, because it's so corrosion resistant, you guys have probably seen like on National Geographic specials where they pull up from Spanish galleons some of the gold coins, and they're like new, or they just have to get some barnacles off them. The interesting thing about it, gold, you'll see it on microprocessors and things like that when you can't have it fail. And essentially, like silver is a great thing to actually put over as an electrical conductor as well as copper. But those corrode, whereas gold does not corrode, so it won't short circuit the actual unit. Anyhow, it's pretty neat, and it does have some characteristics similar to copper and silver. Interesting, all three of those. Not only are they corrosion great conductors, but they actually are antimicrobial as well. Copper being the best, of course, silver being pretty good, and gold resisting that as well. So pretty neat stuff. Okay, so again, I'm going to put a link, and what you do want to watch is the katana video. I'm going to ask you to put down 3 interesting things. Actually, you know what? No, I'm going to save those for the final exam. So make sure you watch the video, and I'm going to ask you, what are some distinctive differences between the Ulfbert sword, which was that Viking sword that we watched the video on earlier in the semester in class, and to the katana? So there's some pretty interesting things between the two. So I definitely, for extra credit, like to see you guys as a class put that together. Okay, that concludes this. Again, I'm going to put the katana video on. The katana video is about 45 minutes long, and again, there's going to be some extra credit on your test for that. And I will talk to you guys later. Take care.